So, hi everyone, good evening. First of all, let me welcome you guys to the Unacademy JEE English. This, as you know, is a brand new channel by Unacademy, which is India's largest online learning platform for IIT JEE. And on this particular channel, every concept of physics, chemistry, and maths are being taught to you completely in English. Now, this is a series that I host for class 12 students, those who are looking to attempt their JEE examination very soon. That is in months of Feb, March, and so on. So here we are quickly going over some key concepts of all the class 11th topics, and then we are also talking about problem solving a bit. Okay, so this is uh, part 6 of quick review of the topic thermodynamics. Now, before we get started with today's discussion, let me introduce myself for those of you who might not know me yet. So my name is Rohit Dixit, and I studied mechanical engineering from IIT Delhi. And for almost past 8 years now, I've been teaching physics for the IIT JEE Mains and Advanced examinations. Now, I myself was All India rank 447 and All India rank 1922 in the two stages of the IIT JEE exams that I took. Now, I also qualified the NTC Stage 2 examination, and I was in the top 1% in the NACP as well. Now, all this experience, all this before this year had been offline. And offline, I had been associated with some of the topmost institutes in the industry where I have coached many students to top ranks in the IIT JEE examinations, both mains and advanced. And now I hope to keep doing so here online with you guys. So, hi Rajesh, how are you? Now, as I said, the last year has had forced all of us to adapt, and every student faced a tough time, including us teachers. We faced a tough time with all the lockdown and no interaction available between students and educators. So one very great way of making sure that this situation does not affect you is by getting yourself the Unacademy subscription. Okay, so this subscription will give you benefits like live classes, where you get to interact with your educator on a regular basis. Now, these classrooms also have live polls and leaderboards, which keep them highly interactive and pretty efficient. Then you have test series and analysis sessions, which again give you a very competitive environment and keep you on your toes. And of course, you have live doubt clearing sessions. So after every three teaching sessions, every fourth session on the Unacademy Plus courses is supposed to be a dedicated doubt clearing session, so that whatever doubts you have after every three teaching sessions, those doubts may be related to the theory, may be related to problem solving, they are taken care of and they don't pile up so that you don't feel the pressure. So next, apart from all these benefits, of course, the Unacademy subscription also gives you a great opportunity to study from the topmost educators all across India from the comfort and safety of your home. So that's a great chance, I think, and which every student must utilize. So how do you get hold of these benefits? And make sure that your J preparation is smooth and steady. So first step towards that is to install the Unacademy app. Now, the moment you install the Unacademy app, you unlock yourself a lot of features like free courses. So there are a lot of courses on the Unacademy Plus app which are completely free. So you can enroll in those even without buying the subscription. Okay. And then you have special classes, so you can enroll in those. So these are again free to attend. All you need to do to attend these is just download the app. And of course, you can take part in quizzes. Okay. So the kind of quizzes that we host every Tuesday. So again, you can avail all these features simply by installing the app. And to unlock these features, you can use the code RD Live. Okay. So that is all you have to do to avail these features. There is no need to buy any subscription for these. Okay. So this will give you a flavor of how your plus subscription is going to be and what all you can expect from your plus subscription. Hello Motilal. Hi Tanya. How are you guys? Next. So when you finally decide to get yourself the plus subscription, and this is how you go about that. You can go to the plus section of your app, select your goal as IIT JEE, and click on the get subscription button. Now, when you do that, you'll be redirected to the payment page. Now, remember here, you will have a box which will say, do you have a code? That is where you can use this code RD Live. This code will give you a 10% off flat on all your subscription fees. Okay. So this gives you a 10% off on all subscription fees. Now you can choose from two kinds of subscriptions, plus or iconic. The prices of those have been laid down, and you will realize when you click on proceed to pay, you will also get a lot of options of choosing from a lot of no cost EMI breakups. Okay, so you can break that payment into a lot of no cost EMIs, whatever suits you. Okay, so next, you guys mostly know about the plus subscription. Let's tell you about the iconic subscription now. The iconic subscription will take your IIT JEE preparation to the next level by allotting you personal coaches. Okay, so from the team of experts of Unacademy, you will be allotted personal coaches. These coaches will closely guide you and mentor you throughout your IIT JEE journey. Then you will also have IIT JEE workshops on regular basis. Then you will have expert guidelines. You will also get a study planner and regular test analysis sessions. So with all these benefits, your preparation would definitely propel ahead. Again, this is more important for students who prefer more individual attention. So those of you who prefer more individual attention can go for this kind of subscription. Okay. Hi Amod, how are you? All right, now if you are looking for one complete, one-stop, one-stop solution for all your preparations, if you are entering your class 11th, then here is a chance to do that. Now, Unacademy is offering you combo subscriptions, so you can take 4 kinds of combo subscriptions, which will take care of your class 11 CBSE, class 12 CBSE, your IIT JEE exams, mains, and advanced, everything. So you don't have to worry about any part of the studies one bit. So the combos that you can go for now is the first combo has the iconic subscription for IIT JEE and the plus subscription for 11th and 12th CBSE. This combo starts at around 4,700 a month. Now you can go for an iconic combo for all three. This combo starts at 550 a month, 5550 a month. Then you could have gone for a plus combo for all three. This roughly starts at 3,000 a month. And then finally, you have a combo where you get plus subscription for IIT JEE and iconic subscription for your CBSE 11th and 12th. And this combo starts at around 3,900 a month. That's a wonderful opportunity. All your study worries are taken care of by a single combo subscription on Unacademy. Single platform will take care of all your study problems. Okay, all right. Now, here is a list of the upcoming tests in January. Okay, so the Unacademy Combat is going to happen on the 17th Jan and the 31st Jan. Then there is a race test that is going to happen on the 10th Jan and 24th Jan. Then Last Mile Target 2021 happening on 9th Jan. Then you have AIM Advanced 2021, which is happening every Saturday now. And then you have unique DPPs, which you get to solve every Monday to Thursday. So make sure you're aware of that and taking part in that. Okay. Now, those of you who are following us on the JEE English channel of YouTube can connect with us on the Telegram app using this link. So this will make sure that you're getting all timely notifications of all the sessions and lectures happening on this channel, and you're not missing out on any of the amazing content given here. All right. So with all that information, why don't we get started with today's discussion then? So as I said, today is part 6 of the quick review of thermodynamics, and today we'll be talking about the next or the last topic of thermodynamics, which is heat transfer. Okay. So what do you understand by heat transfer? You already know that heat is a form of energy which spontaneously transfers from a body from of higher temperature to lower temperature. Now, how does that happen? That usually happens by 3 methods. So there are 3 modes of heat transfer: conduction, convection, and radiation. Now, in the JEE syllabus, you only focus on conduction and radiation. Convection is not part of the JEE syllabus. All right. So let's still compare all the 3 parts. Okay. So when you talk about conduction, conduction is the process in which materials take an active part by molecular action and energy is passed from one particle to another. And this is called conduction. This is a predominant phenomenon in solids. So what happens in solids is that when you provide heat at one end of the solid, so let's imagine you are providing heat here. So this heat will agitate the molecules here, so they will start vibrating more vigorously. So they end up colliding with the next layer of molecules and passing the energy to them and so on. So here what is happening is that different lattices of the solid, they are getting agitated by the heat that they are getting, and in turn they are colliding and passing on that energy to the next layer of molecules, and that is how the energy is traveling from one end to the other. Okay, so this is what happens in conduction. Now, in convection, what happens is that the transfer of energy happens by actual motion of the medium particles from one place to another. Okay, so this phenomenon is predominant in fluids, which is gases and liquids. So you must have seen water boiling, right? So when you put a kettle of water, on a gas, what happens is, imagine this is water and you provided, okay, heat from here. Okay. Now what will happen is that the water molecules which are near the bottom surface will acquire energy due to that heat. Now you realize that part of the water will become lighter. Okay, you guys should remember that when we increase the temperature of a liquid, its density decreases. So as a result, this liquid will rise up, and the heavier liquid on the top will in turn come down. Okay, and again, as this gains heat, this cycle will keep repeating. Now, this kind of current that forms, this is called convection current. Okay, so this is what you call convection currents. So convection currents are established, and you realize that the transfer of energy is actually happening by the molecules moving physically from one place to another. That does not happen in conduction. In conduction, the molecules of one lattice are fixed in its lattice. They are only vibrating and transferring energy to the next lattice. But here, the molecules are physically moving from one point to another and hence carrying energy. Okay. So that is the difference between conduction and convection. Next, you have radiation, of course. Now, radiation is the quickest way of transmission of heat. Okay, and in this form, what happens is that every body emits radiations. Okay, and these radiations can travel from one point to another without any intervening medium required. Okay, so you realize for conduction, you have to have that solid medium. For convection, you have to have that air or liquid medium. But for radiation, there is absolutely no medium required. So any body, when kept at a high temperature, high enough temperature, spontaneously starts emitting radiations in all directions. So it is spontaneously emitting energy in form of electromagnetic radiations. So that is how the heat is getting transferred from one point to another. This does not even require any medium, and this is of course the fastest way of transfer of heat. Okay. Now we will talk about that in detail when we discuss radiation at length. Now let's just quickly compare the three modes. Okay. So the conduction, I told you the heat transfer again. Heat transfer in conduction is due to the temperature difference. As I said, one layer of molecules gets agitated due to higher temperature. Now this ends up colliding with a less agitated next layer and transfers its energy through these collisions. So in conduction, the heat transfer is happening due to the temperature difference. And in convection, you realize the heat transfer is happening due to density difference. Okay, when the densities differ, the molecules actually physically move. And in radiation, heat transfer happens without any medium. Okay. Now in conduction, usually the as I said, one way was vibration of molecules. So vibrating molecules are colliding. Another method of conduction is by motion of free electrons. So free electrons are the electrons that are randomly moving here and there, right? So we talk about this in class 10, 12 in detail. So every material, every metal has a lot of free electrons, and these free electrons are randomly moving here and there. So some guy might be moving here, some guy might be moving here, and so on. So these free electrons keep on randomly moving here, but because they are so moving completely randomly, so you do not see any net movement. However, what happens is if you provide heat at one end. Imagine if you provided heat at one end. Okay. Now what would happen is that the free electrons that are near this surface, these will gain more energy. And let's say on an average, if a free electron moves x distance, then these electrons, because they have gained more energy, would be able to go farther away. So they can carry energy with them, and when they leave, they will leave a positive vacancy behind, which will be filled by these. Okay, so you can think of this as a convection current of free electrons. Okay, so this is very similar to convection, just that here a convection current of free electrons is getting established. So that is also a phenomena of heat transfer in conduction. Okay, and again in convection there is actual motion of particles, which we already talked about, and in radiation the heat transfer is happening by electromagnetic radiations. Okay. Now, conduction is usually the heat transfer in solids, sometimes also in liquids and gases. Now, convection is only related to liquids and gases, and radiation happens to all. Now, conduction is a slow process, so is convection, but radiation is the fastest of all. And finally, conduction happens through irregular paths, and convection happens through irregular paths. However, the radiation happens in straight lines, just like light. The radiations travel in straight lines. Okay, so if you block the way, okay, so you realize that radiation will not reach. Okay, now let's start our discussion of conduction in detail, and let's try and understand what exactly conduction is and how does it work. So here is a picture that has been shown to you. So when there is a rod, metal rod, and at one end you are giving heat. So what you realize is that if you look at the different points on the rod, the temperature here becomes higher, the temperature here is somewhere in the middle, and temperature here is the lowest. So what you realize is due to this temperature difference, there is heat flowing from this end to this end, okay, through conduction. Okay, we will again talk about this in detail now. So thermal conduction is the transfer of internal energy by microscopic collisions of particles or movement of free electrons within the body. So I've already told you that. Now there are two states in thermal conduction that we usually talk about. One is the transient state, when that heat transfer is getting set up, and then eventually you will have a steady state when a constant rate of heat would be transferred. Okay. Now in conduction, the heat flow is within and through the body itself, and conduction can take place in all phases, solids, liquid, and gases, but it is a predominant phenomena in solids. Okay. So here is an example. Here is an example. This is what is happening. So once you are providing heat at this end, once you are providing heat at this end, so due to higher temperature of this side of molecules, they have higher energy, and when they move and collide with the boundary of the next lattice, okay, they can provide transfer that energy to a lower energy molecule which is at a lower temperature. So this is how the heat is getting transferred. The energy is physically getting transferred through collisions. Okay. Next, for us, the more important part is this mathematical law that governs the equations of conduction. Okay. Now, the law of heat conduction is also known as Fourier's law. This is what is the most important thing for us as far as this topic is concerned. This law states that the rate of transfer of heat through a material is proportional to the negative gradient of temperature and to the area at right angles to that gradient through which heat flows. So what I'm saying is dq over dt, which is the rate of flow of heat, is directly proportional to the area and directly proportional to the temperature gradient. So what is temperature gradient? As I said, when you see here, as you move some delta x, you have some temperature change of delta t, right? So temperature gradient is the change in temperature per unit length. So delta T over delta X, that is what you call temperature gradient. Okay, so it is the change in temperature per unit length that you move along the solid. Okay. So this is the mathematical equation. So when I introduce a proportionality constant, you have a K which is called the thermal conductivity. So this is a very important equation. Please remember this. All your numericals for conduction are going to get solved with this equation only. Okay, this is a single equation that you need to know for conduction related questions. Okay, all your questions can be solved using this equation. All right. So next, let's just quickly tell you about the transient state and the steady state. So what happens is that initially when the heat transfer starts to happen, there is for a short while a transient state. As you would know, the word transient means short-lived, right? Transient means short-lived, something which doesn't last for too long. Okay. The transient state, what happens is every layer receives more energy than it passes to the next layer. So what is happening is you are giving some energy here. Okay. Now, because of this, the molecules here got agitated. They are transferring some energy here, but they're receiving more energy than they are transferring. So their temperature will keep on increasing. So initially you realize the temperature of every layer, this will happen with every layer. Every layer will receive some energy and transfer even lesser energy forward. So for some time, you will realize the temperatures of the layers will keep on changing. Eventually, a temperature gradient would be established. Now you realize that the rate of change of flow depends on the temperature gradient. So soon enough, a temperature gradient would be established, which will ensure that the heat getting transferred across one layer is equal to the heat that is being input from here. Now, the moment that happens, so every amount of heat that is getting uh, supplied to the body, if such a temperature gradient establishes, which will ensure that the same amount of heat gets transferred here, the same amount of heat gets transferred here. So now no layer is ends up absorbing the heat. Okay. So now what happens is in this state we see that the temperature gradient, a constant temperature gradient is established and a constant rate of heat flow is also established, and that is what you call the steady state. Okay. So I hope that idea is clear to all. So that's the difference between transient state and steady state. However, you don't need to bother too much about this. Okay. Nobody is going to ask you too many details of the transient state. We mostly analyze situations in steady state only. Okay. So in steady state, you must realize that there is a steady temperature gradient. The characteristics of steady state, maybe I can write. So I let's say in steady state, this is what you need to know. A constant temperature gradient gets established at all points. So in other words, you can also say that the temperature of every layer becomes fixed. So temperature of every layer becomes fixed. Okay, so they do not change. And Q dot in, which is the amount of heat getting supplied per unit time, is equal to the Q transferred across all layers. Across all layers per unit time. So whatever heat is being input in steady state, the same is the amount of heat that gets transferred across all the layers. Okay. So that is what you need to understand about the steady state. These are the two, three things that will happen in steady state, and these will be a basis for analysis. Okay. So why don't we try one problem? Hello Mahi ji, how are you? Hi Raj. See. Okay, now let's try one problem. So this problem is telling you one face of an aluminum cube of edge 2 meter is maintained at 100 degrees Celsius temperature and the other end is maintained at 0 degree. Now all the surfaces are covered by adiabatic walls. Find the amount of heat flowing through the cube in 5 seconds. Okay. Thermal conductivity is assumed to be 209 watt per meter per degree Celsius. Okay. So try and solve this quickly. Let's see. Okay. So again, try and find the dq by dt by the information given. Okay, try and find dq by dt with the help of the information given and multiply it with respect to time. That is how easy this is. This is super easy. Okay, Arya. Okay, let's see. Okay, who all are trying? You can let me know. Okay, so I'm waiting for some answers. Okay, this is very simple by the way. Okay, simply just use the Fourier equation. Okay, so AP says 209 kilojoules. Okay, let's see. So you guys know. Let's see. You guys know that dq over dt, which is the amount of heat flowing per unit second, is Ka dt over dx. Okay, or I can sometimes also write this as Ka minus delta t over delta x. Right. So K I've been told is 209 into A I've been told because the cube has the side 2, so the area would be 4 into delta t is 100, okay, over the delta x would be 2. Okay, so this is how you would have gotten your result for this. So this would have been, okay, 209 to 100. That would have been the dq by dt. So delta q would be equal to dq by dt times delta t. Okay. That would have been 209 into 200 into 5. So that is absolutely correct. 209 kilojoules is absolutely the answer. Well done, guys. Well done. Okay, very nicely done. All right, why don't we talk about the next topic then? Now, what we'll do is that thermal resistance will define something which is called thermal resistance to conduction. Okay. Now, what you realize is if you have a uniform glass slab, then you realize delta T over delta X is nothing but delta T over L. So if you have a uniform glass slab, slab of area of cross section A and length L, then you realize delta T over delta X can be written like this, right? So for this, the equation that I have is dq over dt is equal to Ka by L delta theta. Correct. Now, what we do is we compare this equation to our equation of electrical circuits. So, if you remember, compare with dq by dt equals delta V by R. So, if you remember, we had a very similar equation in electricity, okay, which said that the rate of flow of charge is equal to change in potential difference over the resistance, right? So what we realize is if we draw a parallel, then this term is roughly acting as 1 by R. Okay. So R of any slab can be defined as L over Ka. You realize there also the resistance was defined as uh, L rho over A, right? Or I would have said we sometimes also refer to this as L over sigma A, where sigma was called the conductivity. Correct. So this is how we defined resistance also, right? So what we realize is that this expression is very similar to that expression. Okay. Now in terms of resistance, now we define the law, Fourier law again, and we restate it as Q over T, which is the rate of flow of uh, heat per unit time, is equal to the difference in temperature over the thermal resistance. Okay, where dq q over T is called the heat current. This is called the thermal potential difference, and R is known as the heat resistance. So we can draw an equivalent of these resistances due to in conduction with our electrical circuits. Okay, so you realize what we have is something very similar to Ohm's law, okay, that you guys have all studied in class 10. Okay, V equals IR. So this is the kind of parallel that we can draw here. And now, with the help of that, we can analyze situations where a lot of thermal rods are kept, and you have to analyze their situation. So let's talk about this first. So here you've been told calculate the thermal resistance between the inner surface and the outer surface of a hollow sphere. with inner radius A and outer radius B. Okay, and the thermal conductivity of the material is K. So let me show you this. Let me show you this. This is something that I will help you with. Okay, let's imagine you had hollow sphere with inner radius A and you have outer radius B. So I hope you remember how you would have calculated the electrical resistance. So the method of calculating the thermal resistance is exactly similar to how you would have calculated your electrical resistance. So what you do is first you consider. So imagine this is A, this is. You first consider a shell. First you consider a shell of some radius r and thickness dr. Okay, so consider this. Okay, so consider this shell of radius r and imagine that it has a thickness of dr. Now, come on, look. Now, if I wanted to calculate the resistance of this small shell, तो इसका resistance कितना होता? Let's see. Now, dr would have been, how do I define the resistance? The resistance is defined as L by K times A, right? So L, what would have been the length of this? So the heat is going to flow from here to here, right? The heat is going to flow from here to here. So the length that it has to cross is dr. Okay, length it has to cross is dr. So that would have been dr over K. And what is the area of cross section that it is crossing? The area of cross section that it is crossing is 4 pi r square. Right? When heat is traveling, this is how you can define the dr. This is the resistance of that thin shell. Now you realize all such thin shells of different radii are going to be in series. Now all such shells from A to B will be in series combination, right? So I know for series combination, I simply add the resistances. So the net resistance turns out would be nothing but integral of dr over A times 4 pi r square r, limits going from A to B. So when you do that, what are you getting? You will be getting 1 over 4 pi k. Then you will have B minus A over AB. That is your answer. Okay. That is going to be your thermal resistance between the inner surface of the hollow sphere and its outer surface. Okay, I hope that is clear to all. अगेन इसको इंटीग्रेट करके देख लेना 1/r² का इंटीग्रल क्या होगा -1/r 1/-1/r को जब लिमिट्स डालोगे A to B तो ये आ जाएगा. Okay. If you have any confusion about this, you can let me know. Okay, so this is how you would have calculated the thermal resistance. Okay. Now again, you would have calculated electrical resistance also exactly the same way. Okay, so pay attention to this part. If you are good at your electrical analysis, then you will be good at this part as well. Okay. So this will help you with your current electricity also. So pay attention. That is why this part is very important. Okay. All right. So if there is no doubt, should go forward. Now, if we talk about slabs in parallel and series, now what you realize is that any combination of slabs with temperature differences across them can be now converted into an equivalent electrical circuit. So just imagine you have two slabs like this. So what you can do is if there was this slab S1, S2, S3, you can imagine them as three resistances kept in series. Now you realize you could have analyzed this simply by using the fact that resistances in series become equivalent to R1 plus R2 plus R3. Or you can imagine if you had slabs like this. So this again can be treated as three resistances kept in parallel. Now you know how to analyze that situation also. The point is, whatever situation I have with my thermal slabs, okay, with my slabs conducting heat, I will convert them and draw an equivalent electrical circuit for them. And then I will analyze that circuit using all my normal circuit analysis techniques. Now, all laws, including KCL, KVL, can be applied to analyze this, and turns out the results like Wheatstone bridge and series parallel combination equivalence always remain true for thermal circuits as well. So this is what we call thermal circuit. And in thermal circuit, not only can you use all the analysis tools that you learn for electrical circuits, you can also realize that standard results like the Wheatstone bridge, the balanced Wheatstone bridge, is still applicable for thermal circuits also. And the combination of series, you know that here the net thermal resistance would be simply R1 plus R2 plus R3. And similarly here, the net thermal resistance would be 1 over R1 plus 1 over R2 plus 1 over R3 and so on. So all the results also are replicate perfectly well for our thermal circuits. Okay. So now why don't we solve one question and try to see how that happens. Okay. So here is a question. You have been told that three identical rods of length 1 meter each, having cross-sectional areas of 1 centimeter square each, made of aluminum, copper, and steel respectively, are maintained at temperatures of 12 degrees Celsius, 4 degrees Celsius, and 50 degrees Celsius respectively at their separate ends. You have to find the temperature of the common junction. Okay, find the temperature of the common junction. Where you have been told the K for the copper rod is 400, the K for the aluminum rod is 200, and K for the steel rod is 50. Here is what you can see in your figure. Okay, you have three rods of aluminum, copper, and steel joined together, and the three ends are maintained at this temperature. You have been asked what is the temperature of this junction. What is the temperature here? That is what you are expected to calculate. Why don't you give it a try then? See? Hmm. So give it a try. Again, how do you think you can do this? I hope you remember your KCL. You will solve this using KCL. Okay. So let's imagine that this was an electrical circuit and the resistance here, let's just say was R1, resistance here was R2, resistance here was R3. Okay, now let's imagine that because this temperature seems higher, so the current would have flown from higher temperature to lower temperature. So let's imagine that the current is flowing from here and it is going out of here and out of here, okay, from this junction. So let's call this I3 and let's call this I1 and let's call this I2. So imagine I3 current is entering the junction and I1 and I2 are leaving the junction. Okay. Now what you need to do is you will realize from KCL what can you say that I3 would be equal to I1 plus I2. Now it doesn't really matter which one is coming in, which one is coming out, by the way. I will have that values adjusted later. Now let's just calculate the values of the resistances that we have. What is the resistance of R1? R1 was copper. So length of each rod was this. The cross section area of each was this. Okay. Now for copper, the K is 1 over 400. So R1 would be L1 over A1 K1. Okay. L1 is 1 and K is 10 to the power of minus 4 and this is 400. है ना? So कितना आया देखते हैं. This is 10 by 4, right? It will be 10 by 4 or 100 by 4. Right? 100 by 4. That's 25. So R1 I'm getting as 25. How about R2? Let's try and calculate R2. भाई R2 में क्या होगा? R2 कहाँ है? Aluminium. So yeah. So the conductivity is half, so the R would be double. Okay. So R2 would be 50. And how about R3? R3 you will realize is 1/8 of this. So the resistance would be 8 times this. 8 times this or 4 times this, so 200. Correct? I hope everybody is fine with that. Let me know if you have an issue with this. Okay, so I found all the three resistances. Now all I need to do is substitute the values here. What will be I3? I3 would have been the potential difference across the rod 3, which is 50 minus T. Okay, so assuming that the temperature of the junction is T. So I can say 50 minus T over R3. 50 minus over R3, which is 200, should be equal to I1. I1 is the current flowing through rod number 1. So in rod number 1, it is going from 0 T to 4. Okay, so T minus 4 over R1. So this will be T minus 4 over R1. R1 I calculated as 25 plus I2. So how about I2? I2 I will say is T minus 12 over the K of aluminum, which is 50. T minus 12 over. So this is the final equation that I have using KCL and equations of Ohm's law. Okay, this is nodal analysis and KCL combined. Okay, so now you can solve this. Let's see. 1 to 8. So multiply the entire thing by 8. Let's see what I'm getting. This equals 8t minus 32 plus 40. That's 48. So I'm getting 12 plus 1, 13t. 13t would be equal to 50 plus 80, 130. Turns out T is coming out to be 10 degrees Celsius. That is it. That is how you solve this. I got my answer. The temperature of the junction is 10 degrees Celsius. Okay. Okay, I hope that is clear. Just go through this. All I did was calculated the thermal resistances and then applied the KCL. Okay, so nothing extraordinary there. Applied KCL, calculated the individual currents by calculating the thermal resistances and using the Ohm's law. Okay, and when I finally solved it, I got the answer of temperature at the junction as 10 degrees Celsius. Okay, okay. I hope there is no confusion about this. In case there is, you can let me know. All right. So here is another problem for your practice now. So this says the figure shows a copper rod joined to a steel rod. The two rods are of equal lengths and equal areas of cross sections. Now the free end of the copper rod is maintained at a 0 and the steel rod is kept at 100. You have to find the temperature of the junction. Okay, what is the temperature of the junction? Hurry up, hurry up. Let's see if you figure this out. Hmm. Hmm. So try this. What do you think is the temperature at the junction? Okay, so the situation has been told to you. You have a copper rod, you have a steel rod, they have been joined together. One end of the copper rod is maintained at this temperature, the end of the steel rod is maintained at this temperature. You have to find what is the temperature of this junction. Okay, this should be simple. Let's see if you can figure this out. Mhm. Okay. Okay. The AP thinks it's 10.55. Okay. How about others? How about others? Let's see. Let's see. Then, if anybody has a different answer. Mhm. 10.55. Okay. Yeah, that would be the right answer. Okay. Let's see. Okay. So how you would have solved this? Let's see. So you have been told about these two copper rods that they have equal length and equal cross-sectional area, right? So assume that resistance of this is R1, resistance of this is R2. So if I can calculate the values of R1 and R2, R1 कितना होगा भाई? Let's assume that the length is A and area of cross-section is K and this is 390, right? So ये हमारा R1 होगा, R2 would have been L over 46A. ये भाई ये आ गया. Now if you remember this is R1, this is R2. Temperature here is 0. Let's say here is T and here is 100. You realize if I simply apply Ohm's law, what is the current through here? The current through here would be equal to current through here, right? If I is the thermal current. So I obviously would be T minus 0 over R1, which is L into 390A. And this should be equal to 100 minus T over L into 6A, correct? So you will realize all these would have gotten cancelled, and what you would have gotten was 390T would be equal to 4600 minus 46T. So T would have been 4600 over you had 4 6. So yes, absolutely, this will come around. Yeah, this will come around 10.55. This will be between 10 and 11. No, okay, 10 times 436 would be 4360, and 11 times that would be 76 something, almost 70, 40, 4800 almost. Yes, this is right. So that is the right answer. So congratulations, very well done, Ankit. So yes, you have figured it out. Okay, yes, this is how you solve it. I hope everybody else who's watching is also following this. Okay, this is how you solve it. Forget about the fact that you have thermal resistances and thermal slabs, just convert them into equivalent electrical circuits and solve them like your normal circuits that you have been solving since class 10th. Okay, all right, let's move on to the next problem then. So here is another question. Let's see how you would have done this. So this question is asking you that two rods of materials X and three rods of material Y are connected as shown in the figure. All the rods are identical in length and cross-sectional area if the rod A is maintained at 60 degrees and the junction E at 10 degrees. Then calculate the temperatures of the junctions B, C, and D. The thermal conductivity of X and Y have been given to you. Okay. So let's see if you can calculate this one. So here is the circuit. So you have two rods of material X and three rods of material Y. Okay. And you've been told that the temperatures at these junctions are defined as 60 and 10. Okay. So here. So you have to find the temperature at the junctions B, C, and D. So give it a try, people. जल्दी से ट्राई करो. इसको आप इलेक्ट्रिकल सर्किट पे कन्वर्ट करो फिर से. Okay. So that is the hint that I'll give you. Just convert this into electrical signal or circuits. Okay. So again, you should be good with your analysis of electrical circuits if you want to be good at this. Okay. All right. Let's try this one. So I'll give you a hint. If you compare the two thermal resistances of Y and X, what you realize is that because the thermal conductivity of X is a double, so the resistance would be half. Okay. Can I say if this resistance is R, if the resistance of X is R, then the resistance of Y would be 2R, right? Now your hint is here. Now you can convert this into an equivalent electrical circuit. So you would have realized that you could have done it like this, right? This would have been 2R. Y was supposed to be 2R. R, 2R, and 2R, right? This is your hint. Now you should be able to calculate this. Imagine the potential here is 10, is 60 and 10. Okay. Yeah. So now all you need to do is find the potential here, here, and here. It's B, C, D. B, C, and D. So this should be very, very simple. Okay. First, how will we do it? Okay, let's see. So first, let's imagine if I is the current that I have to find, then you realize all I need to do is find the equivalent resistance between your points A and B, right? A and E. So if this was your point A and this was your point E, what I can say is let's talk about the equivalent resistance. The equivalent resistance between A and B. Okay, for those of you who did not get how I wrote that, if the resistance of this is R, then this is 2R. So let's go over that also one more time. So I've been told that two rods of the material and the three rods of the material Y are taken. All rods have identical length and cross-sectional areas. So for any rod of X, the resistance of X would have been L over KA, which is 0.92 times A. You realize R of Y would have been L over 46A. So that is how I figured this out. What is Rx over is to Ry? That is 1 is to 2. Okay. I hope that is clear. Okay. Now that I know this, now I can simply replace the resistances by some R and 2R. Okay. Now you realize the equivalent resistance between A and E. So what do I need to do for that is, so first of all, let's talk about this. These two are in series, so these two are equivalent to 2R. These two again are in series. These two would be equivalent to 4R. Now I have 4R and 2R in parallel. Okay, 4R and 2R in parallel. How much does that? So 2R, 4R, or 6R. This is the equivalent of this entire section. This part, the equivalent is this. And then you have another 2R in series with this. Right? So plus 2R. This will be the equivalent resistance, right? Let's see how much we are getting. So R cancel. Okay. By 3 plus 2. So that is 10 by 3. 10 by 3 is the equivalent thermal resistance. Now I can calculate the current I. I कितना हो गया? I हो गया 50 over R equivalent. हाँ. Okay, so that is 50 over 10 R in equivalent 15 over R. Now, the moment you know that, if the temperature here is TB, then you know 60 minus TB over 2R equals this I. Therefore, 60 TB over 2R equals 15 over R. That will simply tell you that TB is 30. Okay, I hope you followed this. Now, once I know the temperature at B, it is very, very simple. I know that when I current is entering through this, so it will divide itself in inverse ratios of the resistances. So the resistances are in the ratio of 1:2. So 2/3 will go here, 2I by 3 will go here, and I by 3 will go here. Correct? Again, you need to be good at your circuit solving. You need to remember all these results. And now it is very simple. I can apply this from here to here also, and apply this from here to here also. So I can also say that now here what I'll realize is that TC minus 10, C minus 10 over the resistance R, that should be equal to 2I by 3. So 2 into 15 by R. 3. Right? So from here, let's say what I'm getting. I'm getting TC as 20. Okay, similarly, how about TD? Also, temperature at D minus 10 over 2R should be equal to I by 3 by R to 1 by 3. You're getting is 10 again. Okay, so this is also 20. So these are your answers. Now you will remember one thing that this is forming a balanced V stone, right? Isn't it? I talk about this section. R, 2R, 2R. So obviously, I should have known that the temperature here and the temperature here would come out to be the same. Because that is what happens in a balanced feed stone bit. So I know my answers are correct. Okay, so this is how I got all the three answers. Okay, so temperature at B being 30, temperature at B and C being 20 each. Okay, so take a look at this and let me know if you have any confusion. Okay, this is very simple. Just convert it into your electrical circuits, and I'll analyze them normally, just like you would have your electrical circuits. Okay, take a look at this. Till then, I'll help myself with some water. Okay, this is simple enough. Don't worry. Now let's talk about a little bit of variation. So here you have to find the thermal resistance of a rod having a uniform cross section A and a length L made up of a material such that the thermal conductivity varies linearly from K to 3K. Okay. So here the thermal conductivity of the material is not constant. As you move across the rod, the thermal conductivity K is varying. Imagine this is a rod, the length is L, the area of cross section is A, that is constant. However, what is happening to the thermal conductivity? The thermal conductivity is varying linearly from K to K. There. What do you think thermal resistance of this one will be? Think about this. Okay. So I'll give you a hint. You will have to integrate this. The hint is you will have to integrate for this. Okay, so give it a try. Give it a try. So again, I'll tell you another hint. If you can figure out what the thermal conductivity is going to be at X, what you need to take an element of thickness dx at a distance x from this end. Okay, and then integrate that expression because all such elements will be in series, correct? So इसको जल्दी जल्दी ट्राई कर लो, देखते हैं बाकी. Let's see. So I've given you two hints already. Please try and give me an answer. Wait. Again, this is a very standard form of question, so you should definitely try this. Questions like this are asked in mains and advanced all the time. Yeah, very standard question. Try and solve this. Again, you can let me know if you're trying. Pretty standard question. You should be able to solve this. If you're not, then you should watch me solve this. You should know how to solve this. Very commonly asked problem. Okay. Okay. Anybody trying? So anyone who's trying can write trying in the chat so that I know. I don't know what you guys are doing. So anybody who's trying this problem can write trying in the chat so that I know I am waiting for someone. Okay, there are a lot of people here watching. Just let me know if any one of you is trying. The moment I ask if any one of you is trying, suddenly two people disappear. Okay, still a lot left. Okay, and I hope for your sake that some of you are trying. Again, as I said, this is a very standard problem. So if you are looking for a quick revision, you should be solving these problems. Right. So, so what I'll do is I'll go ahead and solve this. Let's see. So all I need to do is I need to figure out what the lambda is as a function of x, right? So lambda here is 3k, and it is varying linearly. I know it is varying linearly, right? So what I can say is, okay, not tough one, a very standard question, okay? So I know lambda changes from k to 3k in length L. ठीक है, सो पर यूनिट लेंथ कितना चेंज होगा? की क्यों बात की बात K changes from K to 3K in length L. Okay, logo, be happy for him. Then you'll both be happy and gay, no? Okay, so change in K per unit length would be 2K over L. Right, 2K over L would be change in the value of K per unit length. Now, what is the change? Change in K in X length. Now that will be 2K over L times X. So if that is the change, so what is the K at a distance X? K at a distance X would be K plus 2K over L times X. Alright, this is the expression that I have, which tells me the K at a distance X from the one end of the dot. Correct? I don't know what to do because I don't know this what is expected of me because 2 days he's been coming and asking this question. Okay, so I don't know how else to respond to that. All right, all right. Anyhow, that now that I've calculated the value of k at a distance x, I know how to calculate dr now. Right? So what will be dr? R would be the length, which is dx, over area of cross section, which is a over x. Okay. So again, k would be k plus 2k over lx. All I need to do is integrate this from 0 to L, 0 to R. So R, what I'm getting is I can take 1 over AK as common, and then I will it will K again. And then I'll have ln of K plus 2K by Lx going from 0 to L. Hmm. That'll be ln 3. So the resistance that I'll get is L over 2K K square ln. Okay, this is the answer. So go through these steps, and I hope you followed. Okay, okay, good for you, Jackson. Again, let's get back to the studies thing. So this is how you have to solve this. Just go through the solution once and let me know if there is some part of the solution that you will not follow. Okay. All right. Now let's talk about one last kind of problem, which is again a very standard problem when it comes to conduction. Okay, that is the formation of ice in a lake. Okay, I think I need to adjust some options. If I am correct, yeah. So here is another standard form of question which is very frequently asked as far as conduction is concerned, and this problem says that ice starts forming in a lake with water at 0 degrees Celsius when the atmospheric temperature is minus 10 degrees Celsius. Okay. Now, if the time taken for 5 of thickness of ice to be formed is 2 hours, then what will be the time in which the thickness of ice changes from 5 to 20 mm? Okay. So hurry up, try this and let me know the answer. Okay. So let's try this. Let's see if you guys know how to approach this one. Okay, so again, this is a very standard kind of a problem. You should have done this if you have solved your HCV. Okay, you should have solved this kind of problem if you have solved your HCV. If you haven't, then I'll show you how to solve. But first, I want you guys to give it a try, and you can let me know if you are trying to solve this. Okay, give it a try. Hurry up. So let's say I'll wait for you for 2 3 minutes. At least you can let me know if you're trying, right? So that I know who I am waiting for. Uh, so that is actually a problem with time teaching. That is something that I don't feel great about. Again, you guys, no matter how much I tell you to try it, doesn't really matter. Most of you won't even try. Would probably the moment I ask you to try, I would probably switch to the next video. That, trust me, is a bad thing for you students because you need to try these problems. Okay. Second thing is, of course, I can't do much about people creating nonsense, talking nonsense, chat. Again, things like this would never happen in a live class of mine, offline live class of mine. Okay. If you're sitting in my class in front of me, trust me, you won't be able to utter nonsense. Okay, you would be focusing on class. Here that is also like needed. So the people are just looking for class. I don't know. That's a little disappointing. I wish there were more serious students here online. I don't know, online students, why don't they want to be serious about their studies? In offline, you do meet most of the students who are very serious. And I don't know what they are looking for. And trust me, people, it's your future. So better start being serious about it. Okay. Because you will be the one who will be a joke at the end of the day. Okay, if you all you bother about is disturbing the class, not being serious, trust me, it's your own life that you're running. Okay. All right. So I don't think many of you are trying. Maybe most of you don't know how to solve this. So let's go over it. So let's imagine the situation is like this. Imagine a lake. Okay, and imagine it has water. Fine. And then one fine day, the atmospheric temperature went below sub-zero, and of course a lake would start developing some ice. Right? Imagine the temperature here is minus 10 degrees Celsius. Okay, so that is what has been told to us. So let's imagine at any time when some ice has gotten frozen. Now pay attention to this. This is very important. Now let's imagine at some time t, you have ice of thickness, let's say X. Okay. Let's just write that down. Let the thickness of ice X at some time t. Correct. Now, what I can say is that here, imagine, because of conduction, some heat will flow from the water below to the atmosphere, okay, from here to here. At this end of the rod, you will have this temperature, right? And how about the temperature at this end? At this end, it has water which is in contact with ice. So the temperature here, I know for sure, is 0 degrees Celsius. Right now, because of this temperature difference across the two layers of ice, there will be heat that will be getting transferred from the higher temperature to the lower temperature. So let's imagine in time dt, if dq amount of heat gets transferred across the layer, then this dq amount of heat will end up freezing another dx layer of ice, a small dx layer of ice. कुछ कुछ ऐसा हो रहा है, एक dx layer extra jump. Let's write that down also so that you guys follow it completely. So assuming assuming PQ heat gets conducted across ice in time dt. So when this dq heat goes from lower to higher, it will end up freezing another dx layer. Loss of this heat, loss of this will cause additional x layer of water to freeze. Right? That water was already at 0 degree. The water that was touching the ice layer was already at 0 degree. Now, from 0 degree water, if you remove more heat, what will happen is that it will freeze, right? And now I can relate the amount of water that flows. So can I say if the area of cross section of the lake is A? So imagine the area of cross section of the entire lake is some A. A is the area of cross section of the lake. Then what I can say is, so if A equals area of cross section of lake, then what you can say is that dq must be equal to dm times latent heat of fusion, right? And dm can be written as the rho of water heat times. This is dm times latent heat of fusion. Okay. Again, this. Now you also know that this should be equal to dq would also be equal to a over dx. Correct? Now all I need to do is solve it from here. So A would have gotten cancelled out. And what I'm getting is, interestingly enough, getting x dx equals K over this LF delta T dt. So if I integrate this from 0 to x, or rather, let's just find a general term from x1 to x2. From x1 take next to x2 from t and 0 to 2, 2 to 2. Then what I'm getting is x2 square minus x1 square would be equal to 2 times k over this delta t times. Okay. Now, from this expression, you realize that whenever the ice is freezing, all these terms are constant. The K is constant. The density of water, the latent heat of fusion, these are all constant. Okay. So can I say now? Can I say now that x2 square minus x square equals some constant? Let's call that c times t. Right now, I already know that it's from 0 to 5. It's from 0 to 5. So I can say 25 minus 0 equals C into what the time was. The time was 2 hours. And finally, from 5 to 20 when it has to grow. So 400 minus 25 would be equal to C times T. If I divide these, I will realize C by 2 equals 400 minus 25 over 25. Okay, now you can take 25 common. Take 25 common. There will be 1 here and there will be 16 here. Okay. 16 minus 1 is 15. 15 into 2 is 30. T equals 30 hours. That is so. Okay, that is why I had to change that option. Okay, so please remember this is how you solve this. Okay, go over this logic. Okay, very, very standard situation. You will find this problem in HCV also. You will find problems like this being asked in mains all the time. Not all the time, but yeah, very, very standard kind of question that is very likely to be asked in mains. Okay, so the idea is due to the temperature difference across the layer of ice, there is conduction established, and that conduction takes up additional amount of heat from below to the open atmosphere. This additional amount of heat that flows causes an additional thickness of ice to or water to freeze. Now you can relate that with the rate of heat of flow, the conductivity. Okay. Then if you formulate that equation and calculate it, this is the result that you're getting. X2 minus x1 whole square equals 2k over the density of water times latent heat of fusion of water times delta T being the temperature difference across the two layers of water, which will be the surrounding temperature minus 0. Okay, and in T, small t being the time. Okay, now you can use this to find your answer. Okay, and the answer that we got here was 30. So again, you can let me know if you have any issue with that. Or is there any part of the solution that you did not follow? Did you see TB's responded? TB's responded to what? Okay, I'm not sure. What did TB's respond to? Okay. Okay. So she responded to. So did she correct it? Did she correct the solution? Did she include that angular momentum? Okay, so this is what brings me to the end of today's discussion about this topic. Okay, so tomorrow we'll talk about radiation. This is all I had to discuss about conduction. Okay, I will check it out. Oh, she just said it was wrong on Twitter. Okay, so I had told you that it was wrong, right? I had already told you that it was wrong. No worries. I told you, no, she missed one component of the angular momentum. Okay, so that's fine. Okay, we already knew that. Yes. Okay, so this is where I'd like to wrap up today's session. And before I leave you, let me tell you. Yeah, I know. So good to be correct, right? Good to be correct. See, we knew TPs was wrong. All right. So what I'm implying is you can have faith in me. Don't worry about it. Okay, you can trust me. I know what I'm saying. Okay. All right. So anyhow, so let's talk about this. So before I wrap up today's session, let me remind you, if you haven't gotten your Plus subscription and if you're planning to, this is how you can do it. Go to the Plus section of the app, select your goal as IIT JEE and click on that Get Subscription button. Okay. Now, when you do that, you will be redirected to the payment page where you can use this code in a box where which will say, do you have a code? You can use this code RD Live. This will give you a 10% off on your subscription. Now you can also choose from one of the two subscriptions, which are Plus and Iconic. The fees of both these subscriptions has been laid out for you. Now, when you click on Proceed to Pay, you can also select a no-cost EMI option for you to ease that payment for you. Okay. Next, those of you who don't know what Iconic subscription is, let me just quickly tell you. The Iconic subscription will take your IIT preparation to the next level by allotting you personal coaches. Okay. This is what happens from a team of experts. You are allotted personal coaches who personally guide you and mentor you very closely throughout your IIT journey. Okay. You also get a chance to attend IIT workshops, receive expert guidelines, get a study planner, and attend regular test analysis sessions. So, with all these benefits and more individual attention, your JEE preparation will be next. Now, Unacademy is also offering you a single one-stop solution for all your study needs. Okay, so for all the students who are currently going to the class 11, can choose a combo subscription, okay, which will take care of all their class 11 studies, class 12 CBSE studies, boards, the mains, their advanced, all the exams that they are to encounter. Okay, so the combo subscriptions are available, and there are four kind of combo subscriptions available. One where you get the iconic subscription for IIT and plus for your 11th and 12th. Second, where you get iconic for all three. The prices have been mentioned here. Third, where you get plus for all three, in price here. Fourth, where you get icon a plus for your IIT and iconic for your CBSE. Okay, again, prices mentioned here. So you can simply select one that suits you. Okay. Now, let me also quickly remind you, these are the tests, upcoming tests in January. So go over that. Make sure you're not missing out on those. Okay. Now, if you like today's session, then don't forget to press that like button and don't forget to share it with as many people as possible. Okay. So this is quality content being given to you completely free of cost. Make sure you spread the love. Okay. And if you're new to the channel, don't forget to subscribe. Okay. And don't forget to press the bell icon. Okay. Now, the PDF of all the slides used in today's lecture will be available for download very soon. All right. Those of you who are following us on the JEE English channel of YouTube, do not forget to connect with us on the Telegram app using this link, okay? So that you're receiving all the timely notifications of all the lectures and sessions happening here. Now, with that, let's bring this session to the end. And one last time, let me remind you, this is my code, RD Live. So if you like my lectures, if you like me to guide you through your IIT journey, then you can get your Unacademy subscription using this code and enjoy a 10% off on your subscription. Okay. So with that, I'll see you tomorrow. Tomorrow we will cover radiation and we'll try to finish it. Okay. Till then, you guys keep practicing hard, keep studying hard, and take care of yourselves. Bye bye.